Topic 1.1.1, common CPU components and their function, and the von Neumann architecture. So this is the model of the CPU that you guys are going to need to know for the GCSE. So you have the ALU, the arithmetic logic unit. This performs the arithmetic and logical calculations, so addition, subtraction, multiplication, as well as Boolean logical operations, so and, or, and not. CU, the control unit. The control unit controls how data moves around, data flows through the CPU. So think of it like in an airport, the control tower that looks around and makes sure everything's flowing correctly. Okay, now you have the registers. So the registers you need to know for the GCSE is the MAR, memory address register, MDR, memory data register, PC, program counter, and the accumulator. So the registers are like tiny, super fast memory inside the CPU, each with a specific purpose and function. So the MAR holds the address. So if you come to this diagram here, so the MAR is holding the address this is RAM. So this is the main memory. MAR is holding the address for the next instruction it needs to go to. The memory data register is when it's fetching the data from the memory. So it takes load address 5, it takes that from the memory and stores it in the memory data register. The program counter is similar to the MAR and says that it counts the program. So see this program has 7 steps, so 7 points in the memory. So it goes 1, 2, 3, 4, 5, 6, 7. So that correlates to where the MAR is at. So the program counter, the value of the program counter is copied into the MAR, so that the MAR can then find the data in RAM. The accumulator is where the results from the ALU are stored. So let's say we have add 5 plus 5. Okay, so the ALU calculates this, okay, and it stores it in the accumulator. The cache is a small amount of fast memory which provides fast access to frequently used instructions and data. So when in the FE cycle, the fetch execute cycle, instructions and data from main memory are copied into the cache. Because if you think, the instructions and data in main memory that have just been retrieved, fetched, are more likely to be used again than, say, a piece of data in memory from some random application I'm running. So it would make sense to store that, to copy it, to keep a buffer in the cache, so that if it needs to access it again, it's much faster. It can just go to the cache, which is way faster than going to the RAM or the main memory, because the cache is located inside or very close to the CPU. This is a question and mark scheme from, I can't remember which exam paper. So it listed the components, PC, CU, MAR, ALU, and it wanted you to write a description for them in the box. So you only need to put one per box. This one has 3. So for the PC, you need to say it stores the address of the instruction to be fetched from memory and increments in each fetch execute cycle. So it stores the address of the next instruction to be fetched from memory. So let's say it's storing 1. That's going to be copied into MAR, which then goes to here to find load address 5. So you see how when PC is 1, we're looking at address 1. The control unit sends signals to control flow of data. Now, it's very specific in the mark scheme. There was 3 optional words. I said use control flow of data because that's the one that made more sense and is the simplest to understand. So it sends signals to control the flow of data. If you write, this is from the mark scheme, if you write send signals to components, that is not enough. You will not get the mark for this. You could also say, instead of that, you could say it decodes instructions and runs the fetch execute cycle. The MAR, memory address register, stores the address of the data to be fetched from. So okay, so we need to look in address 2. Well, the MAR is going to be storing 2. ALU with arithmetic logic unit performs the mathematical and logical calculations, like I said there.